Creating depth and a sense of scale is always important in lighting, but that's especially the case with exterior environments. In this final introductory clip, we will explore several key features of a technique for creating depth called aerial perspective. Aerial perspective is a method originally used in classical painting to create depth in an image by simulating the effect of the atmosphere on distant objects. Basically, the greater the distance between the camera and the object, the more atmosphere there is between them, and depending on the level of particles in the air and lighting conditions, this will impact the appearance of things further away. As a general rule of thumb, this means that as things get further away from camera, objects appear to lose their saturation, have less contrast, be less detailed, and take on the color of the atmosphere. All of these effects are interrelated, but let's look at some examples that demonstrate each of these concepts. First, in this image, let's look at how the local saturation of objects appears to decrease as they get further away. You can see in the closer image how the green of the trees and the warm hues of the building are far more vibrant in saturation than any of the trees or buildings in the distance. Again, using these examples from the other side of the photo, the closer part of the image has very saturated tones in the building and in the cars parked on the street, whereas you can see in the detail view from further away that the colors are much more muted and gray as that distance increases. Contrast is a measure of the range between the dark and light values in an image. Using this photo, we'll pull swatches from the darkest points on buildings at various depths from camera, and get an idea of what the potential contrast range at each point is. You can see the closest building goes pretty dark, and is nearly black in the windows. Sampling about halfway through the city, the windows are around a middle gray. By the back, the black level is extremely lifted, so you can see that the difference between the darkest and lightest part of each building has much less range as the object gets further and further away from camera. Here's a pretty extreme example. You can see the atmosphere is really having a big impact on this environment. In the foreground, you can still see the details in the tiles and the needles on the trees. In the midground, you don't get quite that level, but you can still see the windows and other larger details. But by the time you get to the background, you can't even make out the windows on the buildings. They basically look like silhouettes, appearing to lose almost all internal detail. This photo also displays all the qualities of aerial perspective, but it's an especially good example of distant objects taking on atmospheric color. Now, it's probably safe to assume that the actual color of the trees in the background is about the same as those in the foreground. But if we sample the colors, look at how much the trees on the mountains in the distance appear to have taken on the blue color of the haze and the sky. The techniques involved in creating aerial perspective are invaluable for exterior environment lighting. In our scene, we will be able to utilize a depth pass in compositing to replicate all of these concepts, and we will cover the implementation of that later on in the course. So for now, we have armed ourselves with foundational knowledge for both the lighting and compositing stages of our workflow. Next up, with these principles in mind, we're going to jump back into Maya and start lighting. I'll see you in the next module.